Laying out a new roadway seems like a simple endeavor. You have 2 points to connect and you're trying to create a simple, efficient path between them. But there are lots of small decisions that make up roadway design, nearly every one of which is made to keep motorists safe and comfortable. Although many of us are regular drivers, we rarely put much thought into roads. That's on purpose. If you're thinking about the roadway itself at all while driving, it's probably because it was poorly designed. Either that or you, like me, are just innately curious about the constructed environment. If you put it in the context of human history and evolution, it's a remarkable thing we're able to put ourselves in metal boxes that hurtle away at incredible speeds from place to place. It's not entirely safe, but it's safe enough that most of the world chooses to do it on a regular basis. And the place that level of safety and comfort starts isn't immediately evident to the casual observer. Hey, I'm Grady, and this is Practical Engineering. On today's episode, we're talking about roadway geometrics and the shape of highways. This video is sponsored by Ting Wireless. More on that later. Designing a road is like designing anything complicated. There are a multitude of conflicting constraints to balance and hundreds of decisions to make. In an ideal world, every road would be a straight, flat path with no intersections, driveways, or other vehicles at all. We could race along at whatever speed we wanted. But reality dictates that engineers choose the maximum speed of a roadway based on a careful balancing act of terrain, traffic, existing obstacles, and of course, safety. If you're going to sign your name on a roadway design, and especially if you're going to choose a speed motorists are allowed to travel, you have to be confident that vehicles can traverse the road at that speed safely. That confidence has everything to do with the roadway's geometry. You would never put a 60 mile per hour or 100 km per hour speed limit on a city street. Why? Because hardly any competent driver could navigate a turn that fast, let alone avoid a hazard, maneuver through traffic, or survive a speed bump. So how do we know what kind of road features are manageable for a given speed? There are three main features of roadway geometry that are decided as a part of the design: the cross-section, the alignment, and the profile. And there are fascinating details involved in each one. The first one, cross-section, is the shape of the road if you were to cut across it. The roadway cross-section shows so much information like the number of lanes, their widths and slopes, and whether there's a median, shoulders, sidewalks, or curbs. One thing you might notice looking at roadway cross-sections is that they're almost never flat. The reason is that a flat surface doesn't shed water quickly. This accumulation of water on the road is dangerous to vehicles, making roads slippery and creating more ice in the winter. So nearly all roads are crowned, which means they have a cross slope away from the center. This accelerates the drainage of precipitation and keeps the surface of the road dry. But not all roadways are crowned. There's another type of cross slope that helps make roads safer. In curved sections, engineers make the outside edge higher or super elevated above the center line. This is also to help with friction. Any object going around a curve needs a centripetal force toward the center of the turn. Otherwise, it will just continue in a straight line. For a vehicle, this centripetal force comes from the friction between the tires and the road. Without this friction on a flat surface, there would be no way to make the turn at all. For example, if I roll this ball down a flat roadway, it's not going to go around the corner of the road because there's no traction. Rubber tires provide this traction against the road surface, but it's not entirely reliable. Rain, snow, and ice significantly reduce friction. Different weights of vehicles and conditions of tires also create variability. Rather than design every curve for the worst case scenario, it would be nice not to have to count on tire friction for this needed centripetal force. Super elevating a roadway around a curve reduces the need for tire friction by utilizing the normal or perpendicular force from the pavement instead. In my demonstration, if I get the bank angle just right, the ball goes around the corner perfectly, even without any lateral friction with the track. Banking roadways also makes them more comfortable because the centrifugal force pushes passengers into their seats rather than out of them. If the super elevation angle is just right and you're traveling at precisely the design speed of the roadway, your cup of coffee won't spill at all around the bend. Super elevation also helps reduce rollover risk by lowering a vehicle's center of gravity. If you pay attention on a highway, you'll notice that the cross slope changes direction on the outside of curves, and you go from a crown to a super elevation. The faster the design speed of the road, the higher the bank around the bend. The shape of curves themselves is the second aspect of roadway geometry I want to discuss. Just like superelevation, the radius of a curve has a significant impact on safety. The tighter the turn, the more the centripetal force needed to keep a vehicle in its lane. Crashes are most likely when radii are small, so engineers follow guidelines based on the design speed to make sure curves are sufficiently gentle. It's not only the curves that need to be gentle, but also the transitions between straight sections. At first glance, connecting circular curves to straight sections of roadway looks like a perfectly smooth ride, but forces experienced by vehicles and passengers are a function of the radius of curvature. So, if you go directly from a straight section, which has an infinite radius, to a circular curve, the centrifugal force comes on abruptly. Another way to think about this is by using the steering wheel. Every position of your wheel corresponds to a certain radius of turn. If straight sections of roadway were connected directly to circular curves, you would have to turn the steering wheel at a transition instantaneously. That's not really a feasible or safe thing to ask drivers to do. So instead we use spiral easements that gradually transition between straight and curved sections of roadway. Spirals use variable radii to smooth out the centrifugal force that comes from going around a bend, and they allow the driver to steer gradually into and out of each curve without having to make sudden adjustments. Even with all those measures to make curves safe and easy to navigate, drivers still usually have a little bit of trouble staying centered in a lane around a bend. This is partly because tires don't track perfectly in line with each other when turning, especially for large vehicles like trucks, but also because the forces are changing and that takes compensation. Because of this, engineers often widen the lanes around curves to provide a little more wiggle room for vehicles. This happens gradually, so it's relatively imperceptible, but if you pay attention on a highway around a curve, you may notice your lane feeling a little more spacious. One other important aspect when designing a curve comes from the simple but crucial fact that drivers need to see what's coming up to be able to react accordingly. Sight distance is the length of the roadway required to recognize and respond to changes. It varies by driver reaction time and vehicle speed. The slower you react and the faster you're going, the more distance you need to observe turns or obstacles and decide how to manage. Sight distance also varies by what's required of the driver. The amount of roadway necessary to bring a vehicle to a stop is different than the amount needed to safely pass another vehicle or avoid a hazard in the lane. Even if a curve is gentle enough for a car to traverse, it may not have enough sight distance for safety due to an obstacle like a wooded area. In this case, sight distance will require the engineer to make the curve even gentler. The final aspect of roadway geometry is the profile, or vertical alignment. Roads rarely traverse areas that are perfectly flat. Instead, they go up and over hills and down into valleys. Engineers have to be thoughtful about how that happens as well. The slope or grade of a roadway is obviously essential. You don't want roads that are too steep, mainly because it would be hard for trucks to go up and down. You also want smooth transitions between grades for the comfort of drivers. But on top of all that, vertical curves also have the same issue with sight distance. Crest curves, the ones that are convex upwards, cause the roadway to hide itself beyond the top. If you're traveling quickly up a hill, a stalled vehicle or animal on the other side could take you by surprise. If that curve is too tight, you may not have enough distance to recognize and react to the obstacle. So, crest curves must be gentle so that you can still see enough of the roadway as you go up and over. Sag curves, the ones that are concave upwards, don't have the same issue. You can still see all of the roadway on both sides of the curve, or at least you can during the day. At night, things change. Vehicles rely on headlights to illuminate the road ahead, and sometimes this can be a limiting factor for sight distance. If a sag curve is too tight, your lights won't throw as far. That has the effect of obscuring some of your sight distance, potentially making it difficult to react to obstacles at night. So, sag curves need to be gentle enough to maintain headlight sight distance. Of course, there are different equations for all these different parts of roadway geometry that can tell you, based on the design speed and other factors, how much crown is required, or how high to superelevate, or the allowable radius of a curve, etc. Different countries and even different states, counties, and cities often have their own guidelines for how roadway design is done. And even then, the speed used by engineers to design the roadway isn't always the one that gets posted as the speed limit. There are just so many factors that go into highway safety, many of which are more philosophical or psychological than pure physics and engineering. It may seem like you can just plug in your criteria to some software that could spit out a roadway project in a nice neat bow. But to a certain extent, highway design is an art form. Designers even consider how the driver's view will unfold as they travel along. If you pay attention, you'll notice newer roadways are less of a series of straight lines connected by short curves and more of a continuous flow of gradual turns. This is not only more enjoyable, but it also helps keep drivers more alert. There are just so many factors and criteria that go into the design of a roadway, and it takes significant judgment to keep them in balance and make sure the final product is as safe and comfortable for drivers as possible. Not many of us are doing a lot of traveling right now, which means you're probably connected to a Wi-Fi network most of the time. But I bet you didn't call your cell phone company to adjust your data plan accordingly. You're paying for a set amount of data per month whether you use it or not, and you may not be using that much at all. Today's sponsor, Ting Wireless, solves that problem entirely. Ting is the anti-unlimited US provider where you only pay for what you use. Pretty much everything I do on my phone gets downloaded ahead of time on Wi-Fi. Podcasts, audiobooks, and YouTube videos. That means I use mobile data for driving directions, emails, and not much else. If you're in a similar boat, take your latest phone bill, go to practicalengineering.ting.com, and use their estimation tool to see how much you would pay. The average bill for a single phone line is just $23 a month. No contracts, commitments, or strings attached. At the end of the month, you just pay for what you used. It works on almost any phone. They offer coverage on 3 nationwide networks, and right now they're offering a $25 credit for fans of the channel. That's basically a free month of coverage just to give it a shot. That's practicalengineering.ting.com, or just click the link in the description. Thank you for watching, and let me know what you think.